Architectural design or architectural software architectural design. Software architecture designing is an important phase of software development life cycle, or simply SDLC. In this lecture, the following topics will be covered: architectural design decisions, architectural views, architectural patterns, and application architectures. Architectural design. First, we define what is architectural design. Architectural design is concerned with understanding how the software system should be organized and designing the overall structure of that system. So, two things you must know: that while designing the architecture, the purpose is to organize the software, means the software components organization and the structure. Architectural designing is the critical link between the design and requirements engineering, as it identifies the main structural components in the system and the relationship between them. Architecture design is basically the designing of requirements, software system requirements. So this means in architectural design, we organize the software requirements and we structure these requirements. The output of architecture design process is an architectural model that describes how the system is organized as a set of communicating components. Communicating components mean the interrelation of different modules or components together. As you know, that the components, or we can say the user requirements, are not independent but rather they are linked together. So this means the components or requirements are communicating each other. Agility and architecture. It is generally accepted that an early stages of agile process is to design an overall system architecture. Remember that we have two categories of process model. One is plan driven and second is agile. And this is discussed in our previous lecture in quite detail, that in plan driven we design the system specification document, and laterally then after the verification of documents we start designing the architecture, and less changes are expected laterally. So we design the architecture after the requirement engineering process. But in agile we skip the documentation, as the requirements are uncontrollable or unstable and changes may occur throughout the requirement engineering. So we start designing the architecture earlier as much as possible, and the properties of that are already discussed. One of the properties is the simplicity in the designing. So based on that design we then laterally start developing. So it is generally accepted that an early stage of agile process to design an overall system architecture. Remember that refactoring the system architecture is usually expensive. Why? Because it affects so many components in the system. What is refactoring? Changing the structure of this system architecture is called refactoring. But that change is to improve that architecture. So refactoring is indirectly improving the architecture, but improving architecture is not an easy, so we must have to carefully design the architecture. This is an example of the architecture of packing robot control system. Here we have a vision system, then we identify the object identification system, then we have two arrows, one towards this and one towards this, and similarly one arrow towards this, and these are also two arrows. What this show? This show we have different components in this system and then subcomponents. For example, if we look to this main component or module, we have two submodules or components, and here also we have two subcomponents. They are linked together, or they work as a one system in a one module. Here these two components are linked. This means they are communicating each other, and this component, subcomponent of this whole subsystem is linked to this component, and the arrow shows that data or message flow from here, or we can say this communicate this does not communicate this, and this subcomponent is in communication with this whole system. This is arm controller and gripper controller. So packing system is linked to these two subcomponents. So this is the simple architecture design, and alternately this architecture is designed from the user requirements. So this shows architecture is the high level design of the system. There are two types of designs. One is high level design of the system, another is a low level design. High level design of the system is also called a software architecture, and the low level design of the system is called the low level design. The example of low level design is object oriented programming, or designing the classes, programming, etc. So the design of individual component, for example, we take example of ARM controller or packing selection system. So designing of this individual unit or component will be through the low level design. Low level design include all the programming syntaxes, database, etc. But here we are talking about the high level design, which is the architecture. One of the important property of architectural design is the architectural abstraction. Abstraction means hiding something or hiding the details. You can look to this slide. Here only the components graphical representation are shown here, and the details are hidden. So this property is called abstraction. Architecture in a small is concerned with the architecture of individual program. At this level, we are concerned with the way that an individual program is decomposed into components, while architecture in the large is concerned with the architecture of the complex enterprise systems that include other system, program components. These enterprise systems are distributed over different computers, which may be owned and managed by different companies. So that architecture is called large, while small is just limited to certain module or some big module, and then we design the different components. But remember one thing, that while designing the architecture, we will hide the detail. Advantages of explicit architecture. 3 advantages. First is stakeholder communication, and this is very much important property, that through the early architecture design, we negotiate with the customers. Similarly to the civil architecture, what we do if we design our house. So we request some architect, he gives us initial proposal, or proposal is from proposal can come proposal request can come from the customer, or architect can prepare the proposal, and then they start negotiating. Even they take weeks and months to finalize the final architecture. So similar is the case here. With architecture, we negotiate, the vendors, the developers, the analyst, and the requirement engineering team start negotiation with the user and customers. So architecture may be used as a focus of discussion by the system stakeholders. So this means with architecture we can purify the requirements. Requirement illustration is already conducted, requirements are collected, but the requirements can be further improved, clarified, can be completed. This is normally the practice in plan driven approaches, but if we are developing software using agile process model, then through early architecture design we start negotiation with the clients or users, and the requirements are collected. The second advantage of explicit architecture is the system analysis. Means that analysis of whether a system can meet its non-functional requirement is possible or not. Remember that we have two types of requirements, three types: user requirement, functional and non-functional requirements. So non-functional requirements are actually the quality attributes of any system, such as performance, efficiency, usability, reusability, portability, etc. And remember that all the non-functional requirements or quality attributes are achieved only with the architecture and the design, the low-level design. So this means architecture play a very vital role. In my personal opinion, I consider the software architecture phase as the most critical phase of the SDLC. The most difficult and the most critical and important phase of SDLC, because it is linked to the requirement engineering as well as the implementation phase. So through architecture we analyze system requirements, so further purification and further understanding and clarification comes through system analysis using the architecture. And we can verify that either or non-functional requirement will be achieved or not with this design. And the third advantage is the large scale reuse. Remember that reusability is a very important property, and this is also the non-functional property, but laterally we categorize the non-functional requirement into either runtime or non-runtime. So this is non-runtime, that we design the architecture is in a way that the components or the programs are reusable in some other systems. And the advantage of this is that it reduces the implementation time and cost also. So the architecture may be reusable across a range of systems. Product line architecture may be developed. Architecture representations: simple informal blocks diagram showing entities. So there is no formulas, no difficult things you apply, but rather informal block and relationships are the most frequently used method for the documenting software architecture. But these have been criticized because they lack semantics, do not show the types of relationship between the entities, nor the visible property of entities in the architecture. Use of architectural model. So why we use architectural model? There should be some advantages. The first is that it is used as a way of facilitating discussion about the system designing. So it facilitates the discussion, and the discussion is not only with the customer users. The analyst can discuss with each other about the requirements and components. Analyst can discuss with the designers, and the discussion among the developers and also with the designers, and then after testers is using the model. A high-level architecture view of the system is useful for communication with the system stakeholders and project planning because it is not cluttered with the detail. Stakeholder can relate to it and understand an abstract view of the system. So it actually shows the abstract view of the system architecture. Thus, it can be easy to negotiate with the stakeholders. They can then discuss the system as a whole without being confused by the detail. It is a way of documenting an architecture that has been designed. The aim here is to produce a complete system model that shows the different components in the system, their interfaces, and their connections. Now come to discuss architectural design decisions. Architectural design is a creative process, so the process differs depending on the type of system being developed. So, architecture, we cannot say that this architecture is correct, this is not. Yes, we can say depend on the type of the system. So, each and every system type possess a different architecture, or we can say that some architecture fit more in particular situation or type of software and not fit in others. However, a number of common decisions span all the design process, and these decisions affect the non-functional characteristics of the system. So, some question arises while architecture design decisions are taken. One question is that is there a generic application architecture that can act as a template for the system that is being designed? What will be the fundamental approach used to structure the system? How will the structured components in the system be decomposed into subsystems? So these are important to know. How will the system be distributed across the hardware cores or processors, or we can say the hardware systems? What architecture pattern or style may be used? So there are a lot of patterns available, and laterly we will discuss about it, that which patterns should be used in which condition. What strategy will be used to control the operation of the components in the system? What architecture organization is best for delivering the non-functional requirements? As I stated that non-functional requirements are achieved through the architecture, so we must know which architecture organization is best. How should be the architecture of the system documented? Architecture reuse. As I stated that reuse is the non-runtime quality attribute, and that is achieved through architecture. Systems in the same domain often have similar architecture that reflect domain concepts. Application product lines are built around a core architecture with variants that satisfy a particular customer. The architecture of the system may be designed around one of the more architecture pattern. So this means many similar type of software can have one common architecture, or it is also possible that one system can have many possible architecture. So architecture of the system may be designed around one or more architecture patterns, so we can select any proper suitable pattern or style. These capture the essence of an architecture and can be instantiated in different ways. Architecture and system characteristics. So these are the quality attributes: performance, security, safety, availability, maintainability are achieved from the architecture. And not only architecture, but laterally we'll discuss that the design pattern, the low level design patterns are also important, and through that we achieve these quality attributes. But remember that low level design or code design depends on the high level architecture. So we first design the high level architecture. In next lecture I will discuss in detail about the architecture views, patterns, styles in detail.